So in this session, we'll solve a problem by the Newton-Raphson method. So the first step is to write the formula for Newton-Raphson. So the Newton-Raphson method for solving the equation of the form f of x equals to 0 is xn plus 1 is given by xn minus f of xn divided by f prime at xn. So let's rewrite the given equation in this form. So we do that by simply taking every term to the left. So we have x cubed plus x squared plus 2x minus 10 equals to 0, which means that our f of x is x cubed plus x squared plus 2x minus 10. And then we also are required to find derivative. So derivative of x, f of x is given by 3x squared plus 2x plus 2. So which simply means that f of xn, we write the same function but replace x for xn. So we'll have x n power 3 plus x n squared plus 2 xn minus 10. And then this means f prime at xn will be given by x 3xn squared plus 2xn plus 2. So putting these values into the formula, we get that xn plus 1, xn plus 1 will be given by xn minus, so what is f of xn will have xn cubed plus xn squared plus 2xn minus 10 divided by 3xn squared plus 2xn plus 2. So this is the formula that we are going now to apply for this particular case. But then we have been told that the solution lies between 1.6 and 1.7. So the first thing we have to test 1.6, when you put into the function, you get the answer to be, from our calculation, 1.6, you get negative 0.144 and 1.7 given by 1.203. So these are negative value, these are positive value. So indeed, our solution lies in this interval. So if you remember the first method we discussed, bisection, so the initial approximation x naught is usually given by the average of these two values that make the interval. So the 1 xl plus xr over 2, which will be 1.6 plus 1.7 over 2, which is 1.65. So this is what we pick as our initial approximation. So therefore we say when n equals to 1, equals to 0, we'll have x 0 plus 1 is 1, be given by x naught minus x naught cubed plus x naught squared plus 2x naught minus 10 divided by 3x naught squared plus 2x naught plus 2. I remember x naught is 1.65, so we'll have x1 equals to 1.65 minus 1.65 cubed plus 1.65 squared plus 2 times 1.65 minus 10 divided by 3 times 1.65 squared plus 2 times 1.65 and then plus 2. So using your calculator, you evaluate this and you should get 1.611787637. And then when n is 2, n is 1, now we get the next iteration. So we'll have x2 will be given by x1 minus x1 power 3 plus x1 squared plus 2x1 minus 10 divided by 3x1 squared plus 2x1 plus 2. This is the formula. Now the answer you get for x1, you don't have to delete it from your calculator. So just now you press in answer and then press in minus and then press in the fraction button in your calculator and then say answer cubed plus answer squared plus 2 answer minus 10. And then you go to the lower on the denominator, 3 answer squared plus 2 answer and then plus 2 and then press the equal sign. When you press the equal sign, you'll get x2 to be 1.1124 and then 489. Now, if you round off the x1 to nearest fourth significant figures, you get 1.612. This other one will give you 1.611. So because 1.62 is different from 1.611, you have to go to the next iteration. We can't stop here because these two consecutive iterations do not converge to the same answer as specified in the accuracy. So n equals to 2. You don't have to delete this answer from the memory of your calculator. So the formula will be x3 equals to x2 minus, then we have this x2 cubed plus x2 squared and then plus 2x2 minus 10 over 3x2 squared plus 2x2 plus 2. So with the answer you got for x2 as 1.611124489, you key in answer and then minus sign and then key in the fraction button and then key in answer cubed, key in plus, key in answer squared, key in 2, key in answer, key in minus 10, and then go to the denominator, key in 3, answer squared, plus 2 answer, then plus 2. If you do the correct, follow that steps correctly, you'll get your x3 to be 1.611124291. Now this third iteration, if you round off to the stated accuracy of 4 significant figures, you get 1.611. Now, since this x2 and x3 gives the same value, then you say the solution is x equals to 1.611 to nearest 4 significant figures. Confirm that if you go to the next step, x4 will give you the same value as we have in x3. This, if you work out, you'll also find out that x4 has the same answer as what we have in x3. So that is how we apply Newton-Raphson method to that particular problem. Thank you.